Hi, in this short video, I will talk about couple stack application. You have learned that stack is a last in, first out abstract data type. So what it is good for then? What kind of application you can find in a stack? Well, one of the application is balance primacy checker. Have you ever wondering, like on a calculator, how does it know you do not have a matching primacy? When you enter like some equation in the calculator, how does it know your parentheses do not match and hence an error in your calculation? You can use stack. And with stack, you can process the symbol from left to right, and the most recent one must match the next closest one. So as you can see here, these two parentheses match, these two parentheses match, and these two here, this outer one, the match. So how do we write a program that can process the list of opening and closing parentheses to check whether they are balanced? Starting with the empty stack, we can process the parentheses string from left to right. If a symbol is an opening parenthesis, we can push to the stack as a signal that corresponding closing parenthesis need to appear later. If a symbol is closing parenthesis, then pop the stack. So every time we have an opening, we add to the stack. Closing, we remove from the stack. When all the symbols have been processed, the stack must be empty if it is balanced. In other words, the number of push for the opening and the number of pop for the closing should be the same, leaving the stack empty. If the stack is not empty, then you know something, either you have an extra opening or extra closing. And here's a code, privacy checker, and I have two test cases on the bottom. One is a balance, the second one is not balanced. So I pass in the string of the opening and closing, and I set balance to true. I create an empty stack, set balance to true, index to 0. Why am I using index? Because I have to use a while loop and not a for loop to go through the symbol. Because I have a two condition. This while loop here iterate every symbol in the symbol string and check whether it's balanced. This is a Boolean termination. I terminate by the flag. So how this work? I get the symbol based on the index. If the symbol is open parenthesis, I add to the stack. Else, if the stack is empty, else I must have a closing parenthesis. And if the stack is empty, this must not be balanced. I have a closing parenthesis with no corresponding open parenthesis in the stack. So I set balance to false. If the stack is not empty, I pop it. And then increment the index. In other words, look at the next character in the symbol string. After this loop finished, if balance and the stack is empty, then you have a balance string, balance parenthesis. Otherwise, you don't. You have unbalanced. So running this program, I have this in Python, in this parenthesis checker. And for this parenthesis checker, I also have the stack function, the implementation in here to make it simple. If I run this program, you won't see like a true or false. So, so for this, it's a balance, and this is not balanced. as you can see. And we could run, for example, I put a breakpoint here. We could run the debugger just to see how this works internally. And I will move up a little. So I'm over here, index is 0. I have an empty stack, balance is true, and let's step into it. The first symbol I got is opening parenthesis, and for opening parenthesis, I push to the stack, next index, next symbol. The next symbol is also opening parenthesis, so I push to the stack. Go then the next index. The next index is also opening parenthesis, so I again push to the stack and increment the index. Now index is 3, while index less than the length of the symbol string and balance. The next symbol is closing parenthesis, so I check whether it is empty, which is not, so I pop it and then increment the index. Next index is 4, and the next character is closing parenthesis. I again check whether it's empty, which is not, so I pop it. Next index. Next index is closing parenthesis again, so I check whether it's empty, which is not, so I pop it. Next index, no more. And then I check whether balance, and if the stack is empty, now it is empty, so I return true. And then check the next one. You can extend this parenthesis checker to more simple. In this case, I can check for example, opening parenthesis, square bracket, and curly braces. I can look for this opening symbol. If any of these opening symbol, then I add to the stack. Otherwise, I check whether it's empty. If it's not, I pop it and check whether I have a matching symbol. The match function, I match the opening to closing, opening square bracket to closing square bracket, opening curly braces to closing curly braces. The way I do the match is I check whether the open, the index for the open is same as the index for the close. When I match, I check the top. The top is the last item I pop it out, and the symbols is the character I have right now. So I check whether the last item I pop out, whether these two items match. In other words, almost any notation you can think of has some type of nested symbol. You can use this balance order. For example, the string quote, single quote, double quote, and triple quote. They had to come in pair. If it doesn't, it's a syntax error. And this can use to check the syntax whether you have matching symbol. Other stack application, recursion. Do you remember when you call a function, when you call yourself, it create what we call like a call stack. So, and when the function, a function 1 call function 2, function 2 call function 3, I call F1 to F2 to F3 for example. And when F3 return, then you unwind the call stack. F3 return back to F2, F2 finally return, you go back to F1, and so forth. is when you have a function, you are using what we call a call stack. It's very similar to the stack operation. The browser history. Every time you go forward or backward in the browser, you click on the link, you go to another page. You click on another link, you go to another page. But if you click on the back button, it go back. So all these pages like a stack in history. The undo, when you type something wrong, you hit Control Z to undo. So this is also stack. Everything you did, they put in the stack so that you can undo or like unwind the stack. Um, can you think about other stack application? Think about it. There are many applications of stack. We will discuss more during class. Thank you.